So a plane is flying 30 degrees north of east. It could be written like that. But I want you to know that this is the same thing, and the east comes first. You've probably seen something written like this. East 30 degrees north. These two statements mean the same thing. 30 degrees north of east, or east 30 degrees north. It seems weird that they're written a little backwards, but hopefully you'll understand what it means. Now, if you look at the coordinate plane, I don't know if any of you ever thought about the coordinate plane as a compass, but it is north, south, east, and west. The coordinate plane is just really a compass, or a compass is a coordinate plane. I don't know which way it goes. So when I say 30 degrees north of east, what does that angle look like? Well, you start at the origin. And this means go to the east first. Okay? So you point to the east. Here it means you point to the east first, whatever comes first there. So you point to the east like this. So a plane is not going due east. That would be due east. From due east, they're going 30 degrees towards the north. So they'd turn this way, that's towards north from due east. And that angle would be 30 degrees. That's what 30 degrees north of east would look like. So you point to the east first, and then you turn towards this direction. Or you turn towards this direction. We'll look at a couple more. If I asked you what is 50 degrees west of north? Okay, this could also be written 50 degrees with a northwest. What does that look like? 50 degrees west of north. So you have a coordinate plane, which is just like a compass. North, south, east, and west. You would point towards the north. So you'd start out going due north. Right here. And then you would go towards the west 50 degrees. Which means you turn this way towards the west, and that angle would be 50 degrees. That's 50 degrees west of north. So you point to this direction and you turn towards that direction. You point towards this direction and then you turn towards that direction. It's a really important skill to have. So if you guys have ever look at an air traffic controller station, right? They're towers and they go 360 degrees around, right? And you think about the person controlling is in the center. And he has to know where that plane's coming from. That plane could be coming from any one of 360 degrees. And this is how they refer to the direction of the plane coming in. So some air traffic controller could be here and says, he spots a plane 50 degrees northwest. Then you have to know what that means. Okay, let's look at a couple more. Two interesting ones. Let's look at 55 degrees west of south. Okay, that could also be written this way. 55 degrees southwest. So if I look at this guy, 55 degrees west of south. So I would point towards due south. There's due south. And I turn towards the west 55 degrees. So that's this angle right here. Point towards the south, turn towards the west. But what if I did this? What if I did 35 degrees south of west? That'd be written 35 degrees west side. What would that look like? Anybody have a clue yet? Yes, it's the same thing. It's the same direction. So if I did 35 degrees south of west, it would mean I'd go to the west. Come on, pen. I'd go to the west and I'd turn towards the south. So I would turn this way 35 degrees. Now, they're different angles, but doesn't it describe the same direction? Wouldn't those be the exact same direction of a plane flying? Because if this angle here is 35, this angle here is 55, because they add up to 90. So when you see south 55 west, it's the same direction as west 35 south, because they're complementary angles. The plane would be flying in the same direction. Okay, and we're going to look at our work today, and you're going to realize we never write direction as obtuse angles. Okay, they're always written as acute angles, because we're going to run into an obtuse angle one today. This looks like a 38, so I'm going to fix it. Okay, any questions on the navigation? How those directions work. It plays a huge everything to do with what we're doing today. So you'll get a little more practice at it when we're doing today. Okay, so if you're at home, I want you to go to Canvas and open up classwork number 5. You guys here have it on paper. If you printed it and you have a protractor at home, then you can just have the printed paper. I'm going to try to show this in a way that everybody could do it at home and here. So I went ahead and did it. I'm going to drag it over to my screen so I can show you guys. Whoops. Let's get out of here. It's back here somewhere. I've got so many monitors now, I never know where my cursor is. All right. So we're going to be starting with this one called triangulation. Now, if you guys have it on paper, you don't have the pink lines, but you can draw that in a minute. Okay, so what triangulation does is it looks at cell phone towers. And based on how that the cell phone tower can determine the direction that the cell phone signal is coming in from. And based on that, they can tell exactly where that cell phone is at any given point in time. Okay, so we're going to try to do this virtually. You guys are going to be using a real protractor if you have it. I want to remind you guys something about geometry. Well, we're going to remind you a lot of geometry today, but one thing I want to remind you about in geometry is something called angle-angle similarity. Okay, if you remember correctly, if you have a triangle and all 3 angles of one triangle are the same as all 3 angles of another triangle, those triangles are similar. Okay, the sides will automatically be proportional. So if we draw a triangle with the proper angles, and that's why we have a protractor, so we could draw it to scale. If we draw a triangle with proper angles on our paper, the sides of the triangle will automatically be proportional to the real triangle. In other words, if you look at my line that I make 10 miles on my paper here, if I assume that's 10 miles and I draw my angles all to scale, the other sides will be drawn in proportion. Okay? So let's take a look at this. Still recording, okay. I'm going to zoom in here a little bit. We're going to look at example 1. Now, those of you who are doing it virtually, in other words, you're doing it on the Google Slides, you're probably going to have to do your work on a separate sheet of paper, okay, and then upload it. Because you're not going to, unless you have the ability to annotate somehow, if you have an Apple Pen or some kind of program and you can annotate, that'd be great. But if not, you're going to have to do your work virtually, or do your work on a separate sheet of paper and upload it. So what we have here is we have 2 cell phone towers. We're looking at number 1. We have 2 cell phone towers, a western tower and an eastern tower. And those towers are 10 miles apart. So I drew a little line to represent the difference between the 2 towers. So the western tower would be at the left side of the line, and the eastern tower would be at the right side of the line. And it says, from the western cell tower, a phone signal is 10 degrees north of east. From the eastern cell tower, the signal is 20 degrees west of north. How far away is the cell tower from each of the towers? So I'm going to do my work off to the side, okay? And then I'm going to go back and I'm going to take my protractor and I'm going to draw it to scale. Okay? So let's take this over here. I'm just going to move my protractor over for a minute. And I'm going to go ahead and do the work, and I'm going to draw a fake triangle. And then I'm going to later go back and put my triangle to scale. Okay? So let me get out of my whiteboard here. So what we have here is we have this. Whoops. Let me, so we have the western tower. This would represent the western tower. This would represent the eastern tower. Actually, I'm going to move it down a little bit so I have more room. So the western tower, the eastern tower, and this distance is 10 miles. Okay, so I'm going to draw it kind of to scale, and then I'm going to later go back and draw it actually to scale. So it says from the western tower, it's 10 degrees north of east. So you would point towards the east and turn 10 degrees towards the north. So this is a very small angle. This is 10 degrees, like that. From the western tower, I would point east and turn to the north 10 degrees. Now from the eastern tower, it's 20 degrees west of north. So what that means is I point to the north and then I turn to the west 20 degrees. Let me see if I could show you what that would look like with a line. Insert. Oh, I can't insert. So you would go towards the north like this. And then you would turn 20 degrees that way. So that angle is 20 degrees. You'd go towards the north and then turn 20 degrees towards the west. So if I lengthen this a little bit, you see I have a triangle. But this angle right here, does anybody know what this angle at E in my triangle is? How much does that angle measure? This angle right here. This measures 70 degrees. because the other one is, I went 20 west of north, so we just talked about that. So 20 degrees west of north is the same as 70 degrees north of west. This would be 70 degrees. Now I actually know what my angle up at the top is. My angle up at the top is 100. Because all the angles of a triangle have to equal 180. Now the question is, how far away is each cell phone from the towers? So I'm going to call this distance little e. That's how far it is from the western tower. I'm going to erase this now because it's going to mess up my picture here. I'm going to call this side little, oh, I was in eraser mode. Darn it. I'm going to call this side little w. And now I have a picture of my triangle. Can I erase this without messing everything up? Probably not. Nope. So what I need to do is you either have an angle side or an angle side angle case here, either one, once you found the 100. You need to use the law of sines, so let's find E first. So I'm going to start with the pair I know, the angle of 100 and its opposite side. So you guys in the classroom now could be doing this on your paper. You guys are at home are probably doing it on a separate sheet of paper, and you're going to upload a picture of your work here. So I'm going to do the sine of 100 over its opposite side, which is 10, equals the sine of 70 over little e. Right? And so we've been doing this, so we know how to do this. So what does little e come out to be? 10 times the sine of 70 divided by the sine of 100. Little e comes out to be, let's go one decimal place, 9.5. And then I do the law of sines again to find little w. So the sine of 100 over 10 equals the sine of 10 over little w. The sine of 100 over its opposite side, which is 10, equals the sine of 10 degrees over its opposite side, which is w. So little w is 1.8. Okay, so now we've got what our picture is supposed to look like. Now we're going to draw it to scale using the protractor. Okay, and it's not necessary in this particular worksheet to draw it to scale, but we're getting the practice because in our next worksheets, it's going to be important to draw it to scale. Okay, and remember, the side lengths will automatically be to scale if your angles are to scale. So you need to always have the angle from each cell phone tower. So I'm going to go ahead and take my protractor. So I'll do it. You guys will be doing it with a pencil in the classroom. I'm going to be doing it virtually. So I'm going to exit this annotation mode here. It's going to be scary because my drawings are going to go away. Okay. And I'm going to move this protractor over. I'm going to do the 10-degree angle from the western tower. So you can use your arrow buttons to kind of get it lined up. And what I mean by lining up is this. When your protractor is lined up properly, that hole in the bottom of the protractor, for you guys that have the protractors in the classroom, will be over the end of the line where the western cell phone tower would be. And the bottom of the protractor has to line up with that 10-mile line. And then I go ahead and draw in the 10-degree angle north of west. So for you guys doing it on the Google Slides, you're going to insert a line. And your line, you can move it later. I'm going to come out here. My line is going to be right here along the 10-degree line. Right there. And it's going to move. You can move it later too. If you can't quite get it exactly, you can move it in a second. Okay, so once you get it there, then you can move your line. You can move the protractor away and move your line back down like this to make a 10-degree angle. And what do you mean straight? Yes. You're trying to draw nice lines, so try to use your protractor to draw them. You can mark the angle and then turn your protractor and draw it. That's about 10 degrees. I mean, it's on our virtual one, it may be a little bit off, but we're doing the best we can. Then on the other angle, I want to make the 70-degree angle. So I take the protractor and now I move it to the eastern tower. And you line it up so that the hole is on where the eastern tower would be. So so you should see the end of that 10-mile line in the hole. And then a 70-degree angle, you'd go 20 degrees, right? We went 20 degrees west of north. So you insert a line. You guys are just going to draw it if you have it drawn. Insert. Let's get over here. Insert a line. And my line is going to go through, here's 90. Then I go 10 degrees that way, 10 degrees that way. So that'd be a 70-degree line. See how I'm going right along that line? So I'm tracing there. And then if I go ahead and click on my protractor and move it away, now I have mine drawn to scale. So if you draw the two angles properly with a protractor from the two towers, so I'm going to resume this for a minute so I can show you guys. This is your western tower. This is your eastern tower. This to scale, what was this, 9.8 miles? 9 point? 9.5. This was 9.5 miles. You can see it's pretty much to scale, 9.5 miles to 1.8 miles. Your sides came into proportion. And this angle is 20 degrees. And this angle down here is 70 degrees. And this angle up here is 100 degrees. The 100-degree angle will automatically be a 100-degree angle if your 70 and 20 are right. Now, does anybody know where the cell phone is in this picture? The cell phone's right here. Right where the two lines we drew met. That's right where the cell phone is. Right where the two lines met. That's where your cell phone is. I'm sorry, what? I can't hear you. You gotta speak louder.
Is it 10 degrees?
10 degrees, right. It's in the directions. It was 10 degrees north of east. Oh, I wrote 20. Sorry. It was 10 degrees. Okay, so learning how to draw them. So it's best to do it separate on a separate sheet of paper and then return to your picture and draw it to scale. Any questions on what we did? Okay, so we'll look at the next one then. The next one, and my bad, I typed 48 here. It's 42 miles. It says the distance between the two cell towers is 42 miles. From the western tower, the cell phone signal is 20 degrees north of east and 48 miles away. How far is the cell phone from the eastern tower? So again, I'm going to do my work off to the side. So I'm going to redraw this, and then I'm going to come back and draw it to scale. So here's the western tower. Here's the eastern tower. They're 42 miles apart. From the western tower, the cell phone signal is 20 degrees north of east. That's where I was getting my 20 degrees, I think, that I did a minute ago. So from the western tower, you go to the east, and you turn to the north 20 degrees. So that's 20 degrees north of east. I'm sorry, did someone say something? I can't hear you. No, but it's 20 degrees. The direction is 20 degrees north of east. From the western tower, you go towards the east this way, and you turn 20 degrees towards the north. And it's 48 miles away. So I'm going to make it a little longer. That's 48 miles away. Okay. So my arrow got a little messy here, so let me fix it up. So that angle is 20 degrees. That's 20 degrees north of due east. Now the question is, how far is the cell phone tower from the eastern tower? So what we're looking for is this. We're looking for how far it is from the eastern tower. Now, I made my 48 look a little longer than my 42, just to get it a little bit to scale. We're going to transfer it to scale in a minute. So what case do I have here? Side, angle, side, 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 angle, side, angle. What case do I have in this one? I got side, angle, side, which means I use the law of cosines. So I'm looking for W, so I'm going to do W squared. I'm looking for little w. And this is the other two sides. Remember, it doesn't matter whether you do 48 squared plus 42 squared or 42 squared plus 48 squared. Doesn't matter. Fix that up. So it's 48 squared plus 42 squared minus 2 times 42 times 48 times the cosine of 20 degrees. Because remember, I've got 20 degrees at the end of the formula, which means the side opposite goes on the left side of the formula. Okay, get used to using that law of cosines formula. And then the other things are just the other two sides, the 48 and the 42. Fill in the other sides. So I don't want people to get hung up on variables. Okay? Whatever angle you have at the end of the formula, its opposite side goes on the left side of the formula, and then you fill in the rest of the formula with the other two sides. So now you can type this. What I have written down here, you can go right to your calculator and type it in. You can type in 48 squared plus 42 squared, if you guys have a calculator or get one, make sure you're doing this, minus 2 parentheses 42. I mean, I literally type it in my calculator exactly how it's written on my paper. And so remember, you get W squared. So if you type that in exactly how it's written in on the paper, you should get 279.159353. But remember, that is not W, that is W squared. So then you have to take the square root of that. So I get 16.7. So this side right here, W, I'm going to go ahead and erase it, is 16.7. Now, I'm still not ready to go to draw this to scale. Remember, angle similarity. In order to draw this to scale, I need the angle from both towers. Okay, we're going to be doing a lot of this thing with cell phone towers. So throughout this project here we're going to do, make sure that you have the angle from both towers. So I need angle E. Before I can draw this to scale, I need angle E. So now you have to revert back to your law of sines to find angle E. So I'm going to go ahead and write mine over here. So now I'm going to do the sine of 20 over its opposite side, which is 16.7, equals the sine of E, I don't know angle E, over its opposite side, which is 48. And you can find angle E. And you probably should maybe get an obtuse angle. I don't know. So the sine of 20 divided by 16.7. Whoops. Sorry. 48 sine of 20. So you guys should be able to be doing this. If you did enough of the problems in the homework, you should be able to be doing this pretty quickly. And don't forget, you got to sine inverse it. 79 degrees, 79.4. Now you're ready to draw it to scale. If you take your protractor and you draw the proper angle from the western tower and the proper angle from the eastern tower, everything else will be to scale. Okay, so go ahead. I'll show you guys how to do it with the one. I was just looking for my, hold on a second. I got so many things going on my paper. Oh, you know what? We did something completely wrong. Anybody know what we did wrong? It's not 79.4. We did something really wrong. And I warned you about it the other day. 79.4 is not correct. You gotta find the angles from smallest to biggest. Wouldn't this angle C up here be smaller than angle E? Because it's across from a smaller side? It's not, I started thinking about it going 79.4 doesn't seem right. I felt like I was supposed to get an obtuse angle for that. Remember, when using the law of cosines, you have to find your angles from smallest to biggest. So let's nix this. We got to find, I'll call that angle C because that's where the cell phone is. So I call it C for cell phone. We got to find that angle first. We did a bad thing. We did not find our angles from smallest to biggest. Angle C has to be next. So what I have to do is I have to find the sine of 20 over its opposite side equals the sine of C over its opposite side, which is 42. The smallest angle we know is the 20-degree angle. That's across from the 16.7. But I've got to find these in order from smallest to biggest. So we got to do that over again. My gut was telling me I needed an obtuse angle there. 59.3. So angle C up here is 59.3. Then to find angle E, I add them up and subtract from 180. A 100.7. Oh, I feel so much better about that. 100.7 degrees. Remember, when using the law of cosines, you have to find your angles from smallest to biggest. If you don't do that, you're going to run into the case that 74 degrees wasn't right. So this angle is 100.7. Okay, now we're going to draw them to scale. So I'm going a little slow here because when I start to draw these to scale and go to my protractor, my annotation goes away. So I want to make sure you guys get that down on your paper before I take the protractor and start moving it, because it's going to disappear. It comes back when I save it, but when I'm doing it, it goes away. Okay. So I need to draw a 107 degree angle from the eastern tower and a 20 degree angle from the western tower. So I'm going to leave this. I'm going to take my protractor. And of course, it's really hard to draw a 107 degree angle, you know, like 107's fine. 100 degree, 100.7 is hard to draw. And if you use your up-down arrows, someone told me this in first period, it's actually a little better. You can move the protractor. I mean, when you're on the Google Slides, it's not perfect, but get it as close as you can. Okay, so a 100 degree angle, this would be 90, and then I'd have to go 10 more. So a 100 degree angle would be right here. So I'm going to insert a line, and I'm going to draw it through my 100 degree angle right here. We got to have an obtuse angle right there. That's about right. It's about a 100 degree angle that I drew. If you guys are using it with the protractors, remember you just mark the 100 degree with a little tick mark, and then you turn your protractor and you can trace it. You guys did that in geometry, I'm sure. So there's a 100 degree angle. Close enough. Can't really do 100.7. So I'll move my protractor away, and you guys can see I have a 100 degree angle there. And then on the other side, I got to draw a 20 degree angle. So I'm going to move my protractor over to here. You make sure that through the hole, the end of that line is through the hole, and I got to draw a 20 degree angle. So I'm going to insert a line, and 20's right here, so I'll go here, and I'll try to go through that 20. It sometimes wants to connect weird places, so that's why it's hard. And I went through the 20 degree line, close enough. It's a little off, but like I said, if you're doing it this way, it's going to be a little off. And there, it's pretty much drawn to scale. And then remember, the cell phone is the person with the cell phone, or the cell phone is right where those two sides meet. That's why it's important to get those angles right. If those angles aren't right, where they meet, you're not going to find the person with the cell phone. What do you guys think? Okay, I'm going to have you guys work on number 3, and I'm going to tell you a little bit about number 3. And these are now all even though my one line says 10 miles and my other line says 48 miles, the rest of those sides are in proportion based on that. Because my angles are drawn to scale, those other sides are in proportion. Okay? Like the other sides based on 48 miles, the other sides of the triangle are the right proportion. Okay, so let's look at number 2. 2 distances. The distance between the two towers is 38 miles. The western cell tower... from the western cell tower, a phone is 21 miles away, and from the eastern cell tower, a phone is 52 miles away. Determine the angles and the directions. So when it says the direction, that means, is that angle 20 degrees north of west? Is that 20-degree angle, 20 degrees east of north? What is the direction? So I'm going to go ahead and do this. Again, not to scale. I'm going to transfer it to scale in a little bit. From the western tower, it's 21 miles away. So the cell phone's 21 miles away here. So let's call this W, let's call this E, and I usually call this one C for cell phone, because that's where the cell phone is. And from the eastern tower, it's 52 miles away. Your goal is to determine the angle and the direction from each tower. So you need angle W and you need angle E. But you got to find them in a specific order. What angle are you going to find first? The smallest, which is E. And then you're going to find C. Even though you only want E and W, you've got to find them in order. So we're going to find E, then we're going to find C, and then we're going to find W. So I'll start you off on E. Okay. I want to know angle E. It's a side, side, side. So I have to use the law of cosines. So angle E is going to be at the end of my formula, which means E squared is going to be on the left side. So it's going to be 21 squared plus 38 squared plus 52 squared minus 2 times 38 times 52 times the cosine of angle E. And remember, you're going to have to do that algebra to find angle E. When you find angle E, you're going to revert to the law of sines to find angle C, and then you'll find angle W, and then we'll talk about it. Okay, this drawing is very much not to scale, by the way. So you guys go ahead and try that, and I'll help you if you need help, but please make sure you find your angles from smallest to largest. Otherwise, you're going to get yourself in trouble. And then we'll talk about the directions of the angles in a minute when you get them. Because one of your angles is going to be obtuse, and we never do direction in terms of obtuse angles. So we'll have to talk about that guy. And let me know if you guys need help. I don't know how to help you guys. I'll try. You guys in the classroom, if you need help, let me know. But this is just a basic side, 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 which we did the other day. Fix my 52 squared here. And you can just go one decimal place. And remember, once you have angle E, you'll revert to the law of sines to find angle C. And then once you have E and C, W is a piece of cake. Okay, so I'll give you guys angle E to make sure you've got that, because if E is wrong, the other ones are going to be wrong. E you should have gotten to be 20.3 degrees if you did E right. So make sure, because if E is wrong, the rest of your calculations are going to be wrong. Remember, that's that kind of crazy algebra you have to do for that. Then once you get angle E, then angle C, you should get 38.8, I think. I don't know about my rounding there, depending on that. But angle C should be 38.8, and angle W should then be 120.9. Okay, so check your work on that one. We're going to kind of need to move on to the next worksheet, so you guys can go back and look at those calculations. Okay, let's talk about direction. So then you're going to go back and you're going to draw it to scale. Okay, for right now, I'm not going to draw it to scale for sake of time, because I want to show you a couple things. Because not only did it say to find the directions from each tower, it also, the angle from each tower, but it also is the direction. So when you go back and draw it to scale, it'll look something like this. Your picture will look something like that when you draw it to scale. Okay, and you guys are going to do that with the protractor. So this angle here is 20.3 degrees. And this angle here is 120.9. But let's talk about the direction of those angles. How would we describe, I'm going to go over here. How would we describe the 20.3 degrees? How would you describe that? Would you describe that west of north, north of west? How would you describe it? North of east? Yeah. Who said that? Did you say that? Like, there's people's masks on. I don't know who's talking. Yes. So at least on the screen, you highlight yellow when you're talking. But in the classroom, I can't tell who's talking. Yes. So it'd be 20.3 degrees north of east. North of east. Okay. If you were right it the other way, it would be the east would come first. Okay, those two things say the same thing. But now let's talk about the 120-degree angle. The 120.9. We can't write angles in direction with obtuse angles. So we have to use an acute angle. So what I usually tell people to do is this. Right at the corner, put a little coordinate plane. Pretend there's a little coordinate plane right here. What would this little angle right here be? Well, wouldn't that just be 120.9 take away 90? Because from here to here is 90. So that would be 30.9, right? That little angle would be 30.9. That's what you're going to use to describe that angle. So it's 30.9 degrees what? North of west, west of north. What is it? Not north of west. West of north. Think about going towards the north straight and then turning 30 degrees towards the west. So that would be west of north. If you want to go north of west, it would be the 60-degree angle or the 59.1. Because then you'd go west and turn to the north, okay? But when you're writing when you have an obtuse angle, you have to write it as an acute, somehow the direction of acute. That 120.9 degrees is the same as 30 degrees west of north. So you go due north, turn to the west, 30.9. Does that make sense? Okay, let's look at the next slide, because this is where we're going to get into the really meat and potatoes of this thing. That was just practice. Okay, so if you guys are in the classroom, you're going to be looking at the forensics one now. Okay. And you guys will go to the next slide on Google Slides. Okay. So I'm going to zoom in a little bit here. All right, so let's talk about this one. This is where it's important to draw it to scale. Okay, so let me hit resume here. You've got this county. So you've got 4 counties here. You've got Jackson County, Adams County, Monroe County, and Madison County. And you've got 2 cell phone towers, A and B. Okay? And we've got to place this cell phone at 2 different times. It pinged the towers at 9:12, and it pinged the towers again at 10:36. So we're going to focus on the 9:12 right now. Okay? What happens at 10:36 has nothing to do with 9:12. So we have no idea what happened with cell phone tower A at 9:12. But from cell phone tower B, it was 7.68 miles away at an angle of 23 degrees north of west. Now, pay attention here. The cell phone towers are 20 miles apart. Okay, so the distance, and here's cell phone tower A, and here's cell phone tower B. So I'm going to draw mine off to the side again. Now, there's a place for you guys to upload your work if you're at home. You're going to upload a picture of your work there. But we've got to answer some questions here. We've got to figure out what county was the cell phone in at 9:12. At a time of 9/12, what county was it in? So I'm going to redraw it over here because I like to work with scratch work first. Here's A, here's B, and they're 20 miles apart. And then I'll draw it to scale on my thing in a minute. And it'll have to be to scale or you won't know what county it's in. Okay, from cell phone tower B, it's 23 degrees north of west. So picture being at point B, going towards the west and turning towards the north 23 degrees. That would be this angle right here, 23 degrees. I'll make it better. This angle right in here would be 23 degrees. And this distance would be 7.68 miles. Okay, what case do I have here? And then I don't know about A, so we'll just draw that. I don't know what it looks like. And the cell phone's up here. What case do I have? Angle, angle, side, angle, side. What do I got? I got a side, angle, side. So I'm going to use the law of cosines. Remember, in the law of cosines, the only thing you can find is the missing side, which is little b right here. That's the only thing I can find using law of cosines in a side, angle, side. So I'm going to do that. I'm going to say b squared equals 20 squared plus 7.68 squared minus 2 times 20 times 7.68 times the cosine of 23 degrees. And this is the nice one. You're trying to find little b, so you can type that in exactly as you have it written on your paper. You can do 20 squared plus 7.68 squared minus 2 times 20 times 7.68 times the cosine of 23 degrees. And remember, you got to square root it. So you get b squared is 176.2. So when you square root it, b is 13.3. Okay, so if you look down below, your answer goes in the boxes down below. Right here at 9/12, okay, how far away was it from cell phone, from tower A? 13.3 miles. Okay, now what county was it in? That's where our drawing has to be to scale. In order for your drawing to be to scale, you need to know the angle from both cell phone towers. So I need to find angle A. Okay. So I'm going to use the law of sines. I'm going to say the sine of 23 over its opposite side, which is 13.3, equals the sine. Oh, do I have to find A? Yep, it's the smallest one. C is the biggest angle. So the sine of 23.3 over its opposite side equals the sine of A over its opposite side. So I am finding the smaller angle first. And then you find angle A. It's 13 degrees. So A is 13 degrees. So now you've got to transfer that to your map. Okay? And you've got to transfer it to scale. So you need to make a 23-degree angle from angle B, and you need to make a 13-degree angle from angle A. where those two lines meet will tell you what county it's in. Okay? So go ahead. I'm going to give some time here for people to catch up on writing. Go ahead and take your protractor if you're there. Put it on angle B. Make a 23-degree angle north of west. From angle A, you're going to make a 13-degree angle north of east. And it's either going to meet in Madison or Monroe County. But until you get those angles proper, you don't know if it meets in Madison or Monroe. So go ahead and draw them to scale and tell me what county you're meeting in. Okay, where'd you guys meet? Monroe? You should have met in Monroe County. So you should have met in Monroe. So that's what you would put here. This was 13.3. Okay. Now you've got one more to do. And let me just tell you before the bell rings, so the at the mall slide 3 is your homework. It's just like this one, only you have 3 time frames instead of 2. So now we're going to work on this time frame. At 10:36, what happens? Well, I'm going to go ahead and redraw my picture. Here's cell phone tower A. Here's cell phone tower B. They only tell me that I'm southeast and southwest. So from cell phone tower E, I'm south of east. So you go due east, go to the south, you're going this way. I don't know what that angle is, but I know I go 7.28 miles. And then from tower B, you go south of west. So you go due west, and then you go to the south like that for 19.28 miles. And then remember, the distance between the cell phone towers is 20. So these two are either going to meet in Adams County or Jackson County, according to the map, right? So your goal is to figure out where they meet. Now you have to find your angles from smallest to largest. Okay, so what angle are you going to find first? Let's call this C down here because that's where your cell phone tower is going to be. Or your cell phone's going to be. What angle are you going to find first? B. So which means little b squared is going to go over here. So 7.28 squared is going to go over there. And then you're going to have 20 squared plus 19.28 squared minus 2 times 20 times 19.28 times the cosine of b. And then you have to solve that for angle B. So you're using your law of cosines. 7.28 squared equals 20 squared plus 19.28 squared minus 2 times 20 times 19.28 times the cosine of B. So now you're going to have to use your algebra to isolate cosine B and then cosine inverse it. And when you do that, you should get angle B to be, I don't know, 21 degrees. Then you have to find angle A using the law of sines, and then you're going to draw it to scale, and you're going to figure out what county it's in. It's either going to be Adams or Jackson. Now, for you guys at home, you're going to have to rotate your protractor to do this properly. Okay, because you got to make your angles go south. So which means you're going to turn your protractor upside down to do it properly. But I'm sure you guys could figure that out. So then you're going to find angle A. You're going to draw it properly, and you're going to tell us what county they're in. Okay? And then your homework is the at the mall one. So it's very similar, only you got 3 time frames. You got to figure out what store they were in the mall. Okay. Any questions you guys have? Because the bell is going to ring for us. Okay. So